All right, so today we're diving into a pretty important topic, at least in the world of deep learning, and that is fairness.
Yeah.
Those biases that can creep into our models and end up, causing some unfair outcomes.
Yeah. Definitely a problem we have to be aware of.
Exactly.
So,
So we're going to be dissecting this 2024 research paper by Yang, Jiang, Sun, and Chen. It's called A Large-Scale Empirical Study on Improving the Fairness of Deep Learning Models. And in this paper, they evaluate 13 different methods for making deep learning models fairer, and they do this without sacrificing accuracy.
right. And that's the key, right? You don't want to just get fairness at the expense of performance.
Totally, totally.
So it's a really tough balancing act. I mean, you want the model to be effective, but you also want it to be ethical.
Absolutely. And it's
Yeah.
interesting because this paper goes beyond just facial recognition and actually dives into image classification more broadly.
Yeah, and they use three different data sets, Celeba, UTK-face, and C410S,
Okay, so
which is really helpful because it gives us a much more comprehensive view, of how these fairness improving methods perform across different types of image data.
to be clear for our listeners out there, we're not just talking about, facial recognition.
Right.
This has implications for all sorts of things. Medical imaging, self-driving cars, object detection, all of it.
Absolutely. And to be clear, for the data science enthusiasts out there, they didn't just use one or two fairness metrics, they used five really well-established ones: SPD, DEO, EOD, AOD, and AED.
Yeah.
And then on top of that, like I was saying before, they factored in accuracy and balanced accuracy as well.
To make sure it wasn't just all about the fairness.
Exactly.
Okay, so before we get into the specifics of each of the methods,
Yeah.
let's talk about what we're even referring to when we say fairness, because I think that can be a very loaded term.
Yeah, for sure.
And we are specifically focusing on group fairness.
Right. That's
is-
the main focus of this paper.
Yeah.
So what we mean by that is that, simply put, we want to make sure that the predictions that a model makes
Right.
aren't skewed based on sensitive attributes, like race or gender or things like that.
Right. So let's say you're looking at loan applications.
Yeah,
The probability of getting approved shouldn't be different for men and women if all the other factors are the same.
exactly.
Okay, so that's where these 13 fairness improving methods that they evaluate come in.
Right.
And they fall into three main categories: pre-processing, in-processing, and post-processing.
Right.
Let's start with pre-processing. What is the general strategy there?
So pre-processing is basically trying to tackle the bias at the source, which is the data itself.
Okay.
So think of it like, cleaning up a really messy data set before you even feed it into the model.
So you're trying to prevent the model from even picking up on those biases in the first place.
Exactly.
Sure.
So they looked at four different pre-processing methods in the paper. Two of them are pretty straightforward: undersampling and oversampling, as the names kind of suggest. Undersampling involves removing samples from the groups that are overrepresented
Right.
to try and balance out the data set. And then oversampling is the opposite, right? You're replicating samples from the groups that are underrepresented.
Makes sense.
Oh.
What about the other two methods?
Yeah, so the other two are upweighting and bias mimicking.
Okay.
Upweighting is kind of cool. It adjusts the loss function during the training process to give more weight to those samples that come from groups that are underrepresented.
So you're basically telling the model, like, hey, pay extra attention to these.
Exactly.
These are important.
Right. These are the ones that might get overlooked otherwise.
Okay.
And then bias mimicking is a little more complex. It tries to make the bias distribution the same across all the different classes.
Okay.
So it's kind of like smoothing out the bumps in the data so the model doesn't latch onto those biased patterns.
Okay, so it's not just about equal representation of the groups,
Right.
but also trying to make the way that they're represented consistent.
Exactly. You want to make the model less sensitive to those sensitive attributes.
Okay, so that was pre-processing in a nutshell. Let's move on to in-processing, where things get a little more interesting.
Yeah, in-processing methods modify the model's training process itself
Okay.
to try and promote fairness. So these methods are really diving into the model's architecture, the learning algorithms, and, tweaking things to nudge the model towards fairer outcomes.
Okay, so instead of manipulating the data beforehand, you're actually changing the way the model learns.
Exactly.
Got it.
Because one approach they looked at was adversarial training.
Yeah?
And this is kind of a cool concept. You essentially introduce an adversary during the training.
Okay.
And this adversary, its goal is to try and predict the sensitive attribute based on the model's representation.
Okay.
So the model's being trained to make accurate predictions for the main task, but at the same time, it's also trying to make it harder for this adversary to guess the sensitive attribute.
So it's almost like a two-player game
Yeah.
where one player's trying to make fair predictions and the other one's trying to expose bias.
A good analogy. That's a good way to think about it.
Okay, what about some of the other in-processing methods?
So another one they looked at was domain-independent training.
Okay.
And this is where you actually train separate prediction heads for each bias group.
So instead of forcing the model to come up with one solution
Right.
that works for everybody,
Right.
it can actually kind of tailor its predictions.
Yeah, you give it the flexibility to learn
Yeah.
specific representations for each group without explicitly relying on the sensitive attribute itself.
Okay, that makes sense.
Another one they looked at was bias contrastive and bias balanced learning.
Okay.
And this one's all about the loss function. It uses these specialized loss functions to try and mitigate bias during the training.
Okay.
So you have this bias contrastive loss, which encourages the model to learn representations that distinguish between groups,
Okay.
but only in a way that helps to reduce bias. So it's like, okay, you can learn about the differences,
Right.
but don't use that information to make unfair predictions.
Right, like you can learn it, but don't use it that way.
Exactly.
Like,
And then you have the bias balanced loss, which encourages the model to make predictions that are independent of the sensitive attribute.
so you're trying to balance those two things out.
Exactly. It's a delicate balance.
Yeah.
But it's really powerful when it comes to mitigating that bias.
So in-processing seems to be a lot more hands-on.
Definitely.
What are some of the other in-processing methods that they looked at?
So they also looked at FLAC, which stands for fairness learning through adversarial correlation reduction, which is a mouthful.
Yeah.
But basically what that does is it tries to minimize the mutual information between the learned features and the sensitive attribute.
So you're trying to make sure that the model is picking up on features that are relevant to the task,
Right.
but not ones that are directly revealing the sensitive attribute.
Exactly. You want it to learn, but not stereotype.
Okay.
Then there's MMD-based fair distillation, which uses this like teacher-student model setup.
Well, it just
So the teacher model is trained on a balanced data set, and then it kind of guides the student model to learn fairer representations.
almost like an apprenticeship in fairness.
Exactly. Like,
Yeah.
watch what I do.
Yeah.
And then finally, there's fair deep feature reweighting, which just focuses on fine-tuning that last layer of the model with these fairness constraints.
So this one is all about just tweaking that final decision-making step.
Exactly. It's a simpler approach,
Okay.
but it can still be very effective.
Okay, so we talked about pre-processing, we talked about in-processing.
Right.
What about post-processing? That's kind of where you try and fix things after the model's already trained, right?
You've got it. Post-processing is all about adjusting the output of the model to make the predictions fair.
Okay,
And we'll dive into the methods and the study's key findings a little bit later.
awesome. Sounds good.
Okay, so let's pick up where we left off and dive into these post-processing methods.
Right, right,
So remember, these methods are all about adjusting the model's output
right.
to try to make the final predictions fairer.
Okay, so it's like applying a filter to the model's decisions to make sure they line up with our fairness goals.
That's a great way to put it, yeah.
Okay.
So they actually looked at 3 different post-processing methods in the paper. One of them is FAIR program, which is kind of interesting.
Okay.
It basically adds a fairness trigger to the input data,
Okay.
and that kind of nudges the model towards making fairer predictions.
Oh, so you're kind of subtly manipulating the input to influence the model's behavior.
Exactly. It's like guiding its decisions
Yeah.
without actually changing the model itself.
Interesting.
They actually tested 2 different versions of this.
Okay.
One that added the trigger, like a patch to the image,
Okay.
and then another one that embedded it like at the border of the image.
Yeah.
And it's just fascinating to see how these subtle manipulations can actually have a pretty big impact
Great.
on the model's output.
So what about the other 2 methods?
Another one they looked at is fairness-aware adversarial perturbation, or FAAP.
Okay, another acronym?
Yep.
What does that one do?
So this one involves perturbing the input data,
Okay.
specifically to kind of obscure the sensitive attributes.
Okay, so you're kind of trying to blind the model?
Exactly. You're adding noise or distortions to the image
Right.
to make it harder for the model to pick up on those sensitive features.
Okay, so By doing that, you're essentially forcing the model to make its decisions
Right.
based on other information.
Yeah, it has to rely on other features for its predictions.
And hopefully those other features are less biased.
Right, exactly.
Okay, so we've talked about the 3 different categories:
Mm-hmm.
pre-processing, in-processing, and post-processing.
Yeah.
Was there a clear winner?
Not really, no.
Okay.
The results varied a lot
Okay.
depending on the data set, the fairness metric they were using,
Right.
and the specific method.
So no magic bullet just yet?
Not quite, but there were some interesting patterns.
Okay.
Pre-processing and in-processing generally performed better
Okay.
than post-processing methods.
Which makes sense, right?
Yeah.
If you can address the bias early on. It seems like that'd be more effective.
It's like getting to the root cause
Right.
before the model has a chance to really learn those biases.
But I guess post-processing still has its place.
It definitely does, yeah.
Especially when you're dealing with these massive pre-trained models.
Right.
That are just way too big to retrain.
Exactly. It would take forever.
Yeah, a computational nightmare.
Totally.
But this study did highlight that the current post-processing methods really need some more work.
Yeah, they definitely have some limitations.
Okay, so pre-processing and in-processing were the winners overall. Were there any specific methods within those categories
Yeah.
that stood out?
One that did really well was bias mimicking, or BM.
Okay.
Remember, that's the one that tries to make the bias distribution uniform across the different classes.
Right, so like leveling the playing field
Exactly.
before the game even starts.
Yeah, and what's cool about bias mimicking is that it kind of combines aspects of both pre-processing and in-processing.
Oh, so like a hybrid approach.
Exactly, and maybe that's why it performed so well.
Yeah, interesting.
Now, they also dug into, why some methods did better than others within each category.
Right.
And they found that overfitting was a big problem for pre-processing methods,
All right.
especially those that involve oversampling.
So if you're duplicating those samples from underrepresented groups,
Right.
it can make the model rely too heavily on them.
Exactly. And then when you apply it to real-world data,
Yeah,
it might not be as fair.
because it's overfit to those specific samples.
Right. It's a tricky balance.
Yeah.
What about in-processing? Anything interesting there?
Yeah, were there any insights there?
Yeah, they found that adversarial training wasn't as effective as some of the other in-processing methods.
Oh, that's interesting, because I would think that if you're trying to prevent the model from seeing the sensitive attribute,
Right.
it would lead to fairer outcomes.
Yeah, you would think so, right. But it turns out that just hiding those attributes
Yeah.
doesn't really solve the problem.
Oh, why not?
Well, for one thing, other attributes can act as proxies
Okay.
for the sensitive attribute.
Oh, so even if you remove gender information,
Right.
the model might still be able to infer it from other things?
Exactly, like someone's job title or something.
Right, right.
And on top of that, trying to completely ignore that information
Yeah,
can actually harm the model's accuracy.
right. It's like trying to solve a puzzle, but you're missing some of the pieces.
Exactly.
Okay.
And then with the post-processing methods,
Yeah.
the results were generally less stable,
Okay.
which isn't too surprising because those methods are still pretty new.
Yeah, still under development.
Exactly. And they pointed out that one potential issue with post-processing methods that try to hide sensitive information is that you might accidentally be hiding information that's actually important
Okay.
for making accurate predictions.
So it's like you're trying to camouflage something,
Right.
but you might end up camouflaging the very thing that makes it unique.
A great way to put it, yeah. So those methods definitely need some more work.
Okay, so we've talked about how the different categories performed,
Right.
and we've talked about some of the reasons why some methods did better than others.
Yeah.
But what about those fairness metrics? Did they make any sense of all that?
They did. Actually, one of the most interesting findings was that all of the methods they looked at
Okay.
were pretty insensitive to the specific fairness metric they used.
Oh, so if a method performs well according to one metric,
Right.
it'll probably perform well on the others.
Exactly. They even calculated the correlations between all the metrics,
Hmm.
and they found really strong positive correlations
Oh, wow.
across the board.
Okay, so maybe the choice of metric isn't as important as we thought.
Well, not so fast.
Yeah.
While the methods themselves might be insensitive to the specific metric,
Yeah.
some metrics might be better than others
Okay.
at actually capturing fairness.
Right, in the real world.
Exactly.
Okay, so it still matters which metric you choose.
It does.
But maybe we don't need to get bogged down in comparing them too much
Right.
if the methods generally perform the same way across all of them.
Exactly.
Okay.
And based on their analysis, they found that AOD seemed to be the most robust and representative metric.
Okay, so that might be a good starting point
Yeah,
for researchers.
absolutely.
Now, they also found that the choice of accuracy metric mattered,
Right.
especially when you're working with imbalanced data sets.
Which, let's face it,
Yeah.
is pretty common.
Yeah, a lot of real-world data sets are imbalanced.
Absolutely.
Okay.
And in those cases, using balanced accuracy, which takes that class imbalance into account,
Right.
is much more accurate
Right.
than using just regular accuracy.
So important to use the right tools for the job.
Absolutely.
Okay, what else?
They also looked at the impact of the data sets themselves.
Okay.
And they found that both fairness and accuracy varied quite a bit
Okay.
depending on the data set.
Interesting.
So, for example, on Celebi, the models tended to have higher accuracy, but the fairness scores were lower.
It's kind of the trade-off.
Exactly. And then on UTK face,
Yeah.
which has both age and race attributes,
Okay.
the models actually performed better on race than on age,
Oh, that's interesting.
which kind of highlights that the specific sensitive attribute you're looking at
Right.
and the task at hand can have a big impact.
So context matters a lot.
It really does.
Yeah.
And finally, they also talked about efficiency.
Right, because if method takes weeks to run,
Yeah.
it's not going to be very practical.
Exactly.
Okay.
And they found that fair deep feature reweighting, or FDR, was the most efficient in terms of time per epoch.
Oh, okay.
Which makes sense because you're just tweaking that last layer
Yeah.
instead of retraining the whole model.
Right, right.
But there wasn't a clear winner in terms of overall training time.
Okay.
It really varied depending on the method and the data set.
So again, it's a trade-off.
It is.
You might have a method that's more effective but takes longer, or one that's faster but maybe compromises fairness or accuracy.
It's all about finding that balance.
It sounds like this is a really complex issue
It is.
with a lot of different factors to consider,
Definitely.
but it's super important.
Absolutely.
Okay, so we'll wrap up our deep dive in the next part,
Yeah.
where we'll talk about the key takeaways and what all this means for the future of AI fairness.
All right, so we've covered a lot of ground here in this deep dive.
We have,
13 different methods, 3
a
categories,
whole bunch of metrics.
3 different data sets.
It's a lot to take in.
What are the big takeaways here?
Well, I think this study really drives home the point that fairness in deep learning
Yeah.
is not just like a one-time fix.
Right.
It's something you have to be thinking about
Right. Yeah.
every stage of the process.
Yeah, it's not like you can just
Except,
sprinkle some fairness dust on it at the end.
yeah, there's no magic fairy dust, unfortunately.
Yeah, so what are some of the practical takeaways?
For researchers in this field, where do we go from here?
Well, one thing that I think is really promising is exploring those hybrid approaches.
Okay.
Combining the strengths of different methods.
Like bias mimicking?
Exactly. That was a great example of that,
Yeah.
where it kind of blended pre-processing and in-processing,
Yeah.
and it seemed to get the best of both worlds.
So instead of thinking of these methods as like completely separate things,
Right.
we need to think about how they can work together.
Absolutely, because bias is a complex issue,
Right.
and it needs a multifaceted approach.
Yeah, for sure. What else? Another area where we really need more research
Yeah.
is in those post-processing methods.
Right, because those are the ones that...
Yeah, they're so important for working with those pre-trained models.
Right, right.
But they're not quite there yet.
Yeah, like we said, they're still kind of
Yeah.
under development.
Exactly.
So I guess the challenge there is to figure out how to...
Adjust the model's output without sacrificing accuracy.
Yeah, and without accidentally hiding important information.
Right. It's a tricky balance.
It is.
What else? Any other big takeaways?
Well, the study also highlighted the importance of really understanding why these biases are happening in the first place.
Right, not just trying to fix them after the fact.
Exactly. You got to get to the root of the problem.
Yeah, it's like with any problem, right?
Yeah.
If you just treat the symptoms,
Yeah.
it might come back.
Well, you're not really solving anything.
Right, so in the context of AI fairness,
Yeah.
how do we do that? How do we understand those root causes?
Well, I think techniques like model interpretation are
Right.
really crucial here.
So basically understanding how the model is making its decisions.
Exactly. If we can see what features the model's focusing on,
Yeah.
then we can start to identify the ones that are leading to those biased outcomes.
Right, and then target those specific.
Exactly. It's about being precise and targeted in our approach.
Okay, so this is obviously a really important area of research.
Yeah, absolutely.
but it also has implications for, all of us,
Right.
even if we're not the ones building these AI systems.
It really makes you think about all the AI that you interact with every day.
Right. Like,
Mm.
it's so easy to think of AI as just this neutral thing.
Yeah,
But it's not. It's built by people,
exactly.
and it's trained on data that we collect.
Right. It's a reflection of us.
Yeah. So we have a responsibility to make sure
Yeah,
that it's fair.
absolutely. We need to be advocating for fairness
Yeah.
as a core principle.
Yeah, it's not just about the technology.
It's about the values
Right,
that
exactly.
we embed in that technology.
Okay, so to wrap things up,
Yeah,
this paper was a great deep dive
it really was.
into the world of AI fairness.
A great overview of the current state of the field.
But it's clear that there's still a lot of work to be done.
Definitely. This is just the beginning.
Yeah, it's an ongoing journey
It is.
to build a more just and equitable future.
And a future where AI benefits everyone.
That's what we're all striving for.
Absolutely.